The problem is from GATE 2022 mathematics paper, question number 14. The problem given is the value of the integration over c z to the power of 100 divided by z to the power of 101 plus 1 dz, where c is the circle of radius 2 centered at the origin taken in the anti-clockwise direction is. The four given options are option A minus 2 pi I, option B 2 pi, option C 0, option D 2 pi I. And the NPTEL reference to solve this problem is Module 1 Lecture 2 of Advanced Complex Analysis Part 1 topic. The title of this lecture is The Argument Principle, Roche's Theorem and the Fundamental Theorem of Algebra by Dr. D.E. Venkata Balaji. He is from Department of Mathematics, IIT Madras. Even you can watch this lecture with this YouTube link. Now coming to the solution. It is given that the curve C is given that Z belongs to C such that mod Z equal to 2, and it is asked to calculate the value of the integration z to the power of 100 divided by z to the power of 101 plus 1 dz over C. Now we solve this problem using the argument principle. We have the argument principle as integration over C f dash of z divided by f of z dz is equal to n minus p, where n is the number of zeros of f of z inside C, and p is the number of poles of f of z inside C, of course counted with multiplicities. So now to solve this problem, we let the function f of z as z to the power of 101 plus 1. Then we have f dash of z as 101 times z to the power of 100. So from this we can see, so integration over C z to the power of 100 divided by z to the power of 101 plus 1 can be seen as 2 pi I times 101 times integration f dash of z divided by f of z dz, where the integration run is over C, that is given by 2 pi I times 2 pi I divided by 101 times n minus p, where n is the number of zeros of f of z. F of z is nothing but z to the power of 101 plus 1 inside gamma, inside C. and P is the number of poles of z to the power of 101 plus 1 inside C. Of course, these are with counted with multiplicity. Since we can see the function f of z given by the polynomial z to the power of 101 plus 1 is entire function. Since we know every polynomial is an entire function, so it does not have any singularities in the whole of complex plane. And in particular, inside the C, it does not have any singularities. So, since f of z as z to the power of 101 plus 1 is entire, so we have the value p as 0 since there are no poles in the whole of complex plane, and in particular there are no poles inside the C. So the value of p is 0. But the question here is, what is the value of n? That is the number of zeros of the polynomial z to the power of 101 plus 1 inside C, and where C is the where C is the circle taken. C is the circle of radius 2 with center 0 in the complex plane. So to find the value of n, we first let for the value of n, we let z to the power of 101 plus 1 equal to 0. Now to solve this equation, it is just enough to see the solutions of the equation z to the power of 101 equal to minus 1. If we observe here that the solutions of this equation z to the power of 101 equal to minus 1 are nothing but the roots of the roots of the 101th roots of the minus 1, and which all lie inside, which all lie on the circle mod z equal to 1. Here it is how it's all 101th roots of minus 1, and all these roots lie on the circle mod z equal to 1. Why all such roots should lie on the circle mod z equal to 1? Here is the reason. Suppose there exists a complex number z naught such that mod z naught is greater than 1, and it is the root of the polynomial z naught power 101 equal to minus 1. Then what we have is, we have z naught power of 101 is equal to mod z naught power of 101. Since we have mod z naught is greater than 1, so mod z naught power 101 is again greater than 1. But since we have, but mod z naught power of 101 is equal to, we have as modulus of minus 1, which is not greater than 1. It is equal to 1. So a contradiction. So if there exist any roots of the polynomial z to the power of 101 plus 1, then all such solutions of that polynomial should lie on the unit circle mod z equal to 1 only. And similarly, if we consider the other case where mod z is less than 1, in that case also we can prove a contradiction, and hence we can say all such roots lie on the circle mod z equal to 1. And since so or since we know any polynomial of degree n has n roots in complex plane, and hence here we have the polynomial of degree as 101, and hence the number of roots of this polynomial are 101, and all such roots lie on the unit circle mod z equal to 1, and we can see mod z equal to 1, the circle lies inside the contour which it is given in the problem, that is mod z equal to 2, and hence we can say since z to the power of 101 plus 1 is of degree 101, and all the roots of this polynomial lie inside C. So we have the value of n as 101, and hence in total we have the value of the integration over C z to the power of 100 divided by z to the power of 101 plus 1 dz equal to 2 pi I divided by 101 times 101 minus 0, and this is nothing but 2 pi I. Hence the answer is option D. Thank you.